In this video, we will solve a question on constraint optimization. The question is, for the production function Q is equal to f of KL, K and L are the units of input required to produce Q units of output, which is equal to under root KL. With price of capital is 4 and price of labor is 2, we have to find out the value of K and L that minimizes the cost of producing 2 units of output. Options are being given, we need to find out the correct option. Okay, so this question is actually the cost minimizing question. Okay, we want to minimize the cost, that is we want to minimize C is equal to what is the cost, that is price of capital times units of capital employed plus price of labor times units of labor employed, subject to the production constraint, that is what is production constraint, that is K times L should be equal to, we need to produce 2 units of output. Okay, so we are being given that price of capital is being given 4, let's write it here 4. Okay, and price of labor is 2. Okay, we write it like this, subject to this production constraint. If I rewrite the production constraint, it will become K into L, transposing it becomes 2 square, which is equal to 4. Okay, I am just trying to save the space here. Now we use the Lagrange's method of solving this kind of question. Okay, so we need to form the Lagrange's function. How do we form the Lagrange's function? We add the objective function and the constraint function, and let me explain it here. First step is we set the constraint equal to 0, that means 4 minus KL is equal to 0. Second step is we multiply this constraint by lambda. Let us multiply it by lambda. So on RHS, if I multiply lambda times 0, it will in fact become 0. Third is we need to set up the Lagrange's function. Lagrange's function is the addition of the objective function and the resulting constraint that we formed. So it will be equal to 4 times K plus 2 times L plus we add this Lagrange's function, that is lambda times 4 minus KL. Okay, this is our Lagrange's function. Now to find out the optimal values of capital and labor, we partially differentiate this Lagrange's function with respect to capital, labor and lambda and solve them simultaneously. Okay, so let us denote L subscript L, that is the partial derivative of this function with respect to labor. Derivative of K, derivative of the first term is 0 because we are taking partials with respect to L. So derivative of L in the second term is 1, we get 2. Then we have derivative of L, here it is 1, so we get minus K times lambda. So we have minus okay, so we get minus lambda times K and we set it equal to 0. Similarly, we have L subscript that means the derivative of this function partially with respect to K. Derivative of K is 1, so we are left with 4. No K is involved in the second term, its derivative is 0. Derivative of K is 1, so we are left with L, that is minus L times lambda is minus lambda L. And we partially differentiate with respect to L now, with respect to lambda. So no lambda is involved in the first two terms, derivative of lambda is 1. We are left with 4 minus KL and we set it equal to 0. Okay, solving further. So if I rewrite it here like this, so can I write lambda times K is equal to 2 in this equation? If I solve it, let us say this is equation 1, and can I write lambda times L is equal to 4? Let us say this is equation 2nd, this is equation 3rd. What we do, we divide equation 1st by equation 2nd, which gives us lambda times K upon lambda times L will be equal to 2 upon 4. Lambda gets cancelled, we get K upon L is equal to 2 upon 4, which gives us K will be equal to 2 upon 4 is in fact is equal to 1 upon 2. Okay, 1 upon 2 times L. Okay, now we need to plug the value of K is equal to this stuff into the third equation. So we will get 4 minus K we got is 1 upon 2 L, and L is being given as here L. We set it equal to 0, so we get 4 minus 1 upon 2 L square is equal to 0, or 1 upon 2 L square is equal to 4, or L square is equal to 4 upon 2 is 2, 4 2s are 8, or L will be equal to under root 8, which comes out to be 2 under root 2. Okay, so units of labor employed will be equal to 2 under root 2. To find out the units of capital employed, simply plug L is equal to 2 under root 2 into this function. Okay, so here, so K will be equal to 1 upon 2. Value of L is 2 under root 2. 2 gets cancelled, so K is equal to under root 2. So we got K is equal to under root 2, L is equal to 2 under root 2. That is the cost minimizing units of capital and labor employed to produce 2 units of output. Okay, I hope I make myself clear in this video. Thank you.